Okay, so just before we start the next example, our next topic, we'll do question 2. So what you have in number 2, wall, the strings both have natural length 1, but the constants are different. So here the k is 2, and here the k is 4. What's the total? The total is 20 meters. Newton per meters. Now, if I call this x, then how big is this one?
20 minus x.
20 minus x. Okay. First part is to calculate the force on the particle when it's in the middle. And then this is actually the second part. Calculate when it's not in the middle, when it's balanced, when it's in equilibrium. Do you remember this word, equilibrium?
Yeah. Well, it's not moving.
Yeah. So that's actually part 2. So I'll do that in a minute. Part 1, it's exactly in the middle.
So 10.
10 and 10.
10.
So, and the k's are 2 and 4. So the force to the left would equal 2. No, it's not balanced in the first example. 2 times 10 minus 1. And then here it'll be 4 times 10 minus 1. So that's 18 newtons left, 36 newtons right. So the total equals 18 newtons to the right. So I can just actually say 18 I newtons.
Why you don't say 36 to the right?
36 right, but 18 to the left. So the total is 18 to the right. The total, yeah.
Why is that I?
Vector I.
I is x.
Yeah.
We take it x, they took it I.
Irish people.
I, J, K, that thing.
Yeah, that's x, y, z.
Mm-hmm.
Why we don't use an x, y, z? It's much easier. Irish people.
It's slightly different. Okay. Here.
I say it again, they will kick me. Right?
Maybe. Okay. What's the force to the left here?
18.
2 times
x minus 1.
x minus 1. And that must equal the force to the right.
So
20
minus 1.
minus x minus 1.
Minus 1. Yeah. So I get, well actually let me cancel this. Make it a 2. So here I get x minus 1 equals 2 times 19 minus x. Because there was a 4 here and a 2 here. So what do I get here? I get minus 2x, so I get
19 minus x.
3x equals 38 plus 1, 39?
What is 2 multiplied 19? How much is it?
38.
Huh?
38. It is.
2 times 18.
So x equals
And 19.
13 meters. Right?
If they are not in balance,
Yeah, what happens if they're not in balance?
you're not sure.
Yeah. Which one force is greater, to the right or to the left? Which is bigger?
To the left.
Right.
To the right.
Yeah.
So what's the total to the right? 18.
Yeah.
So what do you think will happen? Well, this will start moving to the right.
Yeah.
So that's what will happen.
Oh.
Can I have my...
Oh yeah.
If we want to know the position.
That's next, this lesson now.
That's the next.
That's what we're going to do now.
Okay.
Okay. Right. Are we ready for the next lesson?
Yeah.
Now, so far, we have just calculated the force. What's the formula for force?
Minus
F
K.
equals minus k x.
Minus kx. But now we want to calculate the position, the velocity, the acceleration, all these things.
So F equals equal mv squared over r?
Maybe. Maybe not. We'll have to look. Now, let's draw time velocity graph. So imagine you have a spring, and at the beginning you pull the spring, and you let go. Well, hang on a
Come
second.
back.
Yeah.
You pull the string. At the beginning, what's its speed? 0.
Okay.
And then you let go, and what happens? Does it get faster or slower?
Faster.
Faster, then slower,
Zero.
slower,
And then there.
stops,
V is 0.
and then it goes backwards.
Mm.
Uh-huh.
Oh yeah.
So it's going like this.
I have a question just
Yes.
before you start. In the exam, the SUK exam, everything will be drawing? Or
No, just part of it. Yeah. So at the beginning, what's its velocity?
there is 0?
0. And then it gets faster, faster, and then slower, stops.
And the faster again.
And then it starts to go backwards. Faster,
Stop.
slower, stops.
Come on, like
Yeah.
when you do this with the row.
Yeah. It's like with spring or a yo-yo.
Yeah.
Yo-yo. This is a yo-yo.
Where's the-
You know? Anyways, what type of graph does this look like? Yeah, it looks like sine.
Yeah.
Now, let's look at this other one.
What big sum?
Imagine you have your spring, and then I flick it. I hit it.
Okay.
So what's the velocity at the start? Will it be 0?
0.
No, because I go.
Ah.
So it starts with some velocity. So imagine here's my spring, and then I knock it. So it starts to move. But what happens when it moves? The spring pulls it back. So it goes slower. So the other way you could have it,
Faster.
starts fast, and then goes slower, stops, and then backwards, then it gets faster,
Like
stops
the
again.
Like the math class.
Yes,
That's because I'm.
up here. So it stops here and here. What type of graph is this?
Because I'm.
Cosine. Huh? No. I'm sorry, just sine and cosine. So you actually have an idea of the formula for the velocity. Let's call this piece here, we'll call that A. And what does it represent?
Acceleration.
No, acceleration. This part here is A, and this one here is minus A.
Oh, the
What?
The maximum velocity, okay?
yeah.
Yeah, but hang on. All right, we'll do another graph. I want to do another graph actually. I don't want to do that one. That'll be confusing. All right. So this time, let's do time, and let's do position, and let me draw the spring. Okay. So at the beginning,
Scary.
well, it's not. Yeah, it's x is 0, and then you move it. So the spring gets bigger,
Bigger.
and then it gets smaller. And then it goes backwards, and then it gets bigger again. Here,
0.
the x is 0. So that means the spring is at its natural.
So L equal 1.
That's not how you spell natural, is it? Is it?
Yeah. Supernatural.
Oh my goodness. Natural length. When it's here, it's at its natural length because the x is 0. But does that mean the spring is 0? No. It just means there's no extra piece, right? So here I can make a guess. I can say, well, I think x, let me call this A, and here minus A. I think x, the formula should be something like A sine omega t. What does A represent?
Area.
No. A represents the maximum length of the string.
Uh-huh.
Do you understand?
Yeah.
the max speed.
Max length, because now this graph is for x, not for v. That's the maximum length. Okay? Do you understand that? So I'm saying here, a equals the maximum value of x. And I think x should be like this, a sine omega t. Because remember in maths class, sine goes up, down, and up. So that's what I think the x should be. Okay? Now, if we look at the velocity graph, what happens? With this one here, it'd be like cosine. Okay? But we still have a maximum and a minimum. Now, in fact, I can't prove this until we do calculus, but this point here on the graph will actually be a omega, and this one here will be minus a omega. So in other words, the maximum velocity, or maximum speed, will equal the maximum length times omega.
But with the sign just maximum A. Maximum length.
This here? Yeah, A is maximum length, yeah. And V, the maximum velocity, will equal the maximum length multiplied by omega. And I haven't told you what omega is yet.
When do you have to include omega?
Well, the reason for that is, look here. What is the length of my sine graph? How far does it go to? It only goes to 2 pi.
Yeah.
But you know, the springs might go faster or slower. So if I put the omega here, the omega changes how fat or small the graph is. So sine omega, you know, I could make it smaller or I could make it bigger if I change the omega. Anyways, I'm still just trying to get the idea of the formulas to you. So far we have A equals x max and V max will equal A omega. But I haven't said what the omega is. But if you look here for the moment, here on the graph, if this was just a normal sine graph, where would this be? This would be 2 pi. Okay? But if I look at a graph here, this is time and this here is, let's say, x, what will this be? This will be big T. Who can tell me why this will be big T?
Which one?
Here.
Why?
Yeah, why? That's my question. Because look what it does. It starts here, the spring gets bigger, smaller, and then you're back at the start.
It's a circle.
Yeah, it's one loop.
Yeah.
So for this you need big T here, and for this normal graph you need 2 pi.
What is T?
This big T, it's the time, the period time, the time to do one loop. And there's a relationship between the two, and the relationship is this. T equals 2 pi over omega. So therefore, if you want, you can say omega equals 2 pi over T. So now we have a way to find the omega. Look here, please. Let's look at, for example, sine omega t. If I put this omega in for here, I have sine 2 pi over big T, right? Now, if it's at the end of its journey, what will this small t equal? If it's at, everybody listen, if it's at the end of its loop, what will little t be?
0.
No? Ted, do you know? Big T.
Yeah.
Why?
Because that's what big T means, the time at the end. I'm looking at the end now, okay, the end. I'm looking here. At the end, the time will be big T, right? Right? Are we all clear? I need everybody to be clear here. Are we all clear?
Yeah.
Yes? Omega is 2 pi over t. So what happens to the big t's? They cancel. And what do I have?
2 pi.
Sine 2 pi. So this formula here, it works to make this and this the same. If I use omega as this, then it means at the end I'll always get sine 2 pi,
So
which
we
is
have
what
to
I
use
want.
Sine 2 pi from the beginning.
What do you mean?
Don't use that formula.
No, I want you to use this formula. So now you have A equals x max, V max equals A omega,
I want just the
and
last formula.
omega equals
To
t, what did I just say?
2 pi.
2 pi over t. 2 pi over t. So that is formula 1, 2, 3. I have another one to do with you now actually. Yeah, we still have to do acceleration, and we still have to do for v squared. Okay.
Is it the next one?
Yeah, we're doing the next lesson, yeah. Can I go to the next page?
Can we write this one?
Write these formulas down, please, yes.
Just the formulas. we
That's,
use.
yeah, for me, that's enough right now.
What's the name of the lesson?
Oh, it's still continuing with simple harmonic motion.
Can you explain what A means?
This A,
Yes,
it's the maximum
maximum.
length.
Like
Yes. Maximum x. So A equals the maximum minus the natural length.
Oh, yeah.
Yeah. It's the biggest you can make it. Okay. Did you write these formulas down? I need you to write these down. Okay.
The omega equal 2 pi over t?
Yeah.
The capital E?
Capital T, yeah.
Okay.
Now, there's two other formulas, and I won't try to explain the proof of them. It's too difficult.
You don't want the proof.
Well,
the last formula. This will be better.
We need calculus to prove it, and we haven't done calculus in class yet. So the next formula is the maximum acceleration. And that will equal omega squared times A. And likewise, if you want, you could say the maximum force will be equal to m omega squared A.
What's A what?
Maximum acceleration, A max. And then the last formula is V squared equals omega squared A squared minus x squared. And what's really, really great about this formula at the end, the great thing about this formula is the V here, it doesn't need to be the maximum. It can be any time. And the x here can be any x. Whereas these formulas are for maximums only. Only formula number 5 that I gave you is not for a maximum. It can be used anytime.
So the question will, he will say, I want the maximum.
Yes.
uh,
Yes. Write these down and I'll give, of course, I'll write these down and I'll do an example. So these are all called the simple harmonic motion equations, if you want to give it a name.
For the last one,
Yes.
this is really bad.
Hang on.
Why? So don't say- don't say-
Yes?
For the last one, there is a new proof. So
Proof for 4 and 5, I can't do it until we do calculus in maths class. Whereas for 1, 2 and 3, I can give you a kind of rough reason. So, let's see. Sorry, I'm just going back to our formulas. So there's 1, 2, 3. and then, whoops, there it is, 4, 5. Do you have 4 and 5 now?
Yeah.
Okay, so let's have a look at an example now. Okay, so for example,
Mr. Steven,
yes,
do the hardest question.
no.
Because usually we make in the class the easy question for the homework to the hardest question.
No. We have to start with the easier ones. Okay, so you have a particle, and it's moving with simple harmonic motion, and it has, okay, so here's our particle. Now, when the x is 4 meters, the speed
Which one you are?
is 6 meters per second. You don't have it there. And then when the x is 3, oops, this should be smaller. When the x is 3 meters,
What's amplitude?
that's the A.
Amplitude A?
Yes, that's the word.
Acceleration.
No, big A is amplitude. When the x is 3, the speed is, do you think it'll be faster or slower?
Slower.
No, faster, because if I start here and let go, it's going to get faster as it gets smaller. It gets slower when it gets bigger, because the bigger it is, the more force there is, and it gets harder and harder to move. So it's bigger, so it's going to be 8. So the question is, well, basically find the maximum velocity, acceleration, the time, basically find everything. Now, which formula do I need to use here? There's only one formula I can use. Which one?
V squared.
Yeah, because you can only use that one at any time. So I'll use it here. V squared equals, what's it?
You want, what do you want?
Omega squared.
Omega squared, a squared minus x squared.
Yeah.
Right, let's use the formula.
Tell them again.
I'm going to just need to go to the next page. Okay, so that's 6 and 4. And this one is 8 and 3. So the first one, 6 and 4. So 6 squared equals omega squared, a squared minus 4 squared. And then for the other situation, it will be 8 squared equals omega squared, a squared minus 3 squared. So that's good. Why is that good?
Cancel the W.
Yeah, you have 2 equations.
So cancel the A and the
Yeah.
beta.
What you can do is you can divide both of these equations if you like. So here I get 36 over 64 equals a squared minus 16 over a squared minus 9. Because you can cancel those.
And the A you can cancel those.
No. Okay. So I can say 36 a squared minus 9 equals 64 a squared minus 16.
Okay.
So I get 36 a squared minus 300 and 36 60 minus 36, 24. 324
Yeah.
equals 64 a. No, I don't want to be silly here. I should simplify it before multiplying it out. So here I can cancel this down. 18, 32, 16, 9. That's it?
Yeah.
9a squared minus 81 equals 16a squared minus 256.
And you can do it in for the other way, right? That you want to start it and you.
Yeah, you can, yeah. So here I get 7a squared, and then I have 256 minus 81. My goodness, 175.
Yeah.
So, what's wrong? Are you losing your mind or something?
25.
What, this over this?
Yeah, 25.
Which is good, because then what does a equal?
5.
A equals 5. So that is the maximum x. Now we should find omega. So I can put that back into, say, yeah, let's say the first one. 6 squared equals omega squared a squared minus 4 squared. So 6 squared equals omega squared a squared minus 4 squared. But I know what a. What's a?
5. 25.
So that would be,
25.
yeah, 25. 25 minus 16 is 9. Yes?
And,
So I get
36 minus
36 equals 9
9. Double square.
omega squared.
Take the 9 that side.
Yes. So I go to the next page. So I get now omega equals 6. If I square root this, be 6, 2. Yeah?
Yeah, 2.
2. That's the omega. Now I can also find what the maximum velocity is. What's the formula for that? That's a omega. Yes? So what will V max here be? 2 multiply 5. So 10 meters per second. Yes? Right?
Yeah.
What else do I need? The time.
Go to 4.
T equals, what's the formula? 2 pi over omega.
Yeah.
Yeah.
What's the omega here? 2.
2.
So they cancel.
5.
So T equals 3.14 seconds. Find the amplitude, the period. So the last one now is the average speed. Oh no, and maximum acceleration. So maximum acceleration, what did I say the formula was? I think omega squared A.
Omega squared.
So that means A max will equal 4 times A. What was A? 3, was it?
5.
5. 4 times 5.
20.
20 meters per second squared.
Can you go back to write the question from the beginning?
I don't know. Last thing is to find the average speed. Now, do you remember, I think this was like the very first week or maybe the second week, but the average speed equals the total distance over the total time. Now, we have the total time, don't we? What's the total time? 3.14. But what's the total distance? Who can tell me the total distance?
Go up. Uh, 5.
What do we think? Is it 5?
Yes.
10. 20. Because it has to go, picture this, it starts here. It goes up to 5, back down,
Oh yeah. Yeah.
down, and back up.
Yeah.
So it goes 5, 5, 5, 5. So the total distance
20.
for in one loop is 20.
Yeah.
So this is actually 20 here. Can you calculate this, please?
6.36.
So that's the average speed. What is this? Oh my goodness. Yes. Go up
Yes.
to the last page.
From the
Here?
beginning. From the beginning.
Have-
For the beginning.
The beginning. Did you not? The very beginning.
Yeah, the first one.
Oh, guys.
Oh yes.
Oh, goodness.
Because you was writing quickly.
I wasn't writing quickly.
And what's the differences between this way and the Vmax?
This V is the V in the middle.
Uh,
The V max is the V, the biggest V. Like for example, here. Here it starts at 0. Then it gets faster, 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 and slower, slower, slower. So here is like V, 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 V max, and then V, 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 V,
Oh.
V, V. So the V is for anything in the middle,
Can you
and
go
V
down?
max is only the biggest V.
Can you go down?
But I don't think Jing Dong has this yet.
Sorry.
But you know this is online. Like I put the video online. Yes.
A is the distance.
Huh?
A means distance or speed.
A, which A? Big A or small A?
Big deal.
Big A is the maximum distance. Small A is the acceleration.
Can you go down, please?
Huh? Have what tomorrow? Maths class? Yeah.
So the A is the same as the x that we used previously in the previous lesson.
No, it's the maximum X.
A is the maximum x that we used in the previous lesson. Or is it x plus the normal length?
Smile
A is the maximum X, which is the maximum length minus the natural length,
Smile for the line.
which is just X. So it's the maximum X.
Smile for the line.
Mr. Sleep,
Yes.
go down, please.
Ten.
Yeah, for the
Nice
line.
to meet you.
And the line
Yeah.
for the smile for you.
Who said that? Someone on Massive.
What?
On worksheet number 2, how many questions do you have?
7. No, more. 10.
Okay.
University.
Yes.
I won't use the toilet.
Go.
You can ask Centroid.
Oh yeah, about the centroid.
Centroid, what about it? Centroid means the center of the triangle.
Yeah, and if I
The formula is x1 plus x2, careful, x1 plus x2 plus x3 over 3, and y1 plus y2 plus y3 over
What's
3.
the formula?
That's the
you use
centroid.
here?
Give me a minute. Which formula? At the top.
Yeah.
X squared what was it?
V squared.
V squared equals omega squared a squared minus x squared.
Why do you use that?
It's the only one I can use.
His question is actually, he's asking if the centroid is has the same distance to every point on ABCs of the.
The centroid. What one is it? It's the one where. Here, I'll just draw it here for you, Albert. It'd be easier if I draw it. Can you look here, Albert? Here's your triangle, okay? If I take a point here and go to the middle, and I take a point here and go to the middle, and if I take here and go to the middle, the centroid is this.
So but it's the same thing as it's the center for all the 3 points.
Yeah, I would call it like the average point of the tree, yeah.
But the distance is not the same.
No, I wouldn't necessarily
Only
think.
one is-
No, it's not. No.
Center means it's the center, so it should be the same.
Well, it's centroid, not center, so it doesn't have to be the same as center.
Mr. Stephen.
Yes.
Nice to meet you, please.
Yes.
So how can we integrate the center?
Centroid. You add x1, x2, x3, divide by 3.
It's the midpoint for three
It's
points.
yeah, it's the midpoint for 3
Yeah,
points.
but if there is a weight on it, it's different.
If there's a weight on it, it's different.
Yeah.
But then it's not the centroid. Then it's the center of gravity. We did the formula for center of gravity, didn't we? You multiply each one by the weight and divide by the total weight.
No, you have to use more. Because last season we studied that technique. He got stuck in centroid.
Nice to meet you, please.
Mm.
Oh, this is center.
Yeah, so the centroid is 2 plus 5 plus 3 over 3. So 5, 6, 7, 8, 9, 10. So 10 over 3, and then 1 and 3 and minus 1. So 10 over 3 and 1 is the centroid. So they're telling you in this example, you need to prove that the center of gravity of this is the centroid. Now, in fact, you don't need that, because I did that, it's not for you.
So center of gravity and centroid is the same.
In only if the weights are equal, yes.
So for this, to prove this, we just say that the weight are the same. So it's
Yes, that's what the important thing there.
It's just one sentence. The weight is the same.
Oh, that's enough for me. You can say that the centroid, that the center of gravity becomes the centroid, because if the weights are equal, what happens is all the weights cancel in the fraction, and you're just left with the formula for centroid. It's fine for me. Yes.
Nice to
next
meet you.
page. I'm going to move down very slowly. This way it'll make you go faster.
And it's faster.
Go faster, go.
No, it's so fast.
No, not too fast. Come on.
Please go up.
Ah.
Please.
He asked for the acceleration.
He asked for everything. Everything. That's why I did everything.
Omega squared. No, you didn't.
I'm going down. I'm going down. I'm going down, Jing Dong.
Okay.
Where are you? Come on. Go, 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 go.
Please stop. Please stop.
It's 20 right here.
Yeah, the reason for A is 20 is it goes up 5, down 5, down 5, and up 5. So it's 5 plus 5 plus 5 plus 5.
Go down, please.
Yes.
Yes.
The end.
What's 20 over 3.14? Why? Yeah.
Total distance over total time. Yes.
For center of gravity, if they say it's the center of the point, like all the
What's the
yeah,
distance?
it's just the center.
What is
spot.
distance?
Wait, hang on. I can't answer two questions at the same time. I'm not that talented. Albert is talking to me, Mustafa.
Sorry.
Albert.
For the center of gravity, we also take into consideration their mass, their weight, their how heavy it is.
Yes.
Yeah, then
Centroid, you don't care. Okay. Right. Next example. So, I cannot. So here, a particle moves so that its position is given by this formula.
Can you go back? Sorry.
Yeah, go ahead, but you'll miss the stuff here. So in this example, I tell you the position equals 2 sine 4t.
The position.
The x, yeah. So if I draw the graph for position, for example, there's x and there's t. It'll go like this. What's this value here? 2. And down here? Minus 2. And this here is big T. Yes? What's the formula for t? 2 pi over omega, which equals 2 pi, and what's omega here? There's omega, and here is A, and here is omega. So that's 4. So that is pi over 2, and that is 1.57. Yeah, well, I just want it like this in decimal. So anyways, the question is, show that it's simple harmonic motion. Now, we can't really do it properly again because we don't have calculus. So for the moment, to show that it's simple harmonic, all I would like you to do is say what the A is and what the omega is. And you can say it, therefore, simple harmonic. Because of the graph as well. If the graph goes like this, it's simple harmonic motion. Okay? If it's not, like, maybe if the graph's like this, what's the name of this motion? If it's like this, what do you call it? You call it linear motion. And if it's like this, simple harmonic motion. Okay? Anyways, we won't worry about that too much. Okay. The question now, find x if t equals pi over 16.
Okay, what is HM?
Simple harmonic motion. So here you have x. X equals 2 sine 4t. So x equals 2 sine 4t. So x here will equal 2 sine 4t. Pi 1 over root 2, isn't it? 2 over root 2. Root 2? 1.41? Is that right?
Why is
It is, yeah.
equal to sine for
They give you that. They tell you that at the start. It's given.
So it's in this x equal to sine. 14.
Come on, come on,
Okay.
come on, come on, come on, come on, come on. I have to go. Right. Next part is, what is the A when the velocity equals 4 root 3? Now, okay.
V squared, no. He wants
No.
the A.
He wants the small a. Now, he says here x equals 2 sine 4t. In other words, x equals a sine omega t. The a is 2 and the omega is 4.
He
Okay.
given that also?
It's
X
a
equals
new
A.
formula.
Now, well, I showed you this already, but I've given you 3 new formulas. Now, please, wait. These formulas can only be used if he gives you this. So, if he gives you this, the formulas you can use are this.
There's 3.
These 3. That's only if he gives you this one, then you get this one for free and this one for free. But only if he gives you this, which is actually very unlikely.
So this will be in the exam? Or we have
Unlikely.
What's that?
And maybe, but probably not.
So we don't have to memorize it?
Well, I'm telling you, if you want to get an A star, and you want to get everything right on the exam,
Minus a.
minus A, yeah. So now he wants
So
the...
if you give us x equals a sine wt,
Yes, you can now get these for free. Okay, so he wants the A if the V is 4 root 3. So I use this formula. 4 root 3 equals, what's big A? What's big A? Come on. 2. Omega? 4. Cos omega?
4.
4, and then t. So I get cancel. Root 3 over 2 equals cos 4t. So
T is 15.
cos inverse root 3 over 2. Can you tell me what this is, please, in radians? This here?
So it's pi over.
Oh yeah, root 3 over 2 cos is pi over 3, isn't it?
I think so.
I'm sure I can
1
check
over
it.
2 is sine 30, so cos 30 is root 3 over 2.
Pi over 6 or pi over 3?
Pi over
30.
Pi over 6, okay.
Yeah, pi over 6.
So this is pi over 6, but I can bring the 4 down. So it's actually going to be pi over, what?
24.
24. That's what the t is equal.
we don't.
124.
Pi over 6, isn't it? Yes?
13.
Yeah, that's pi over 6.
Yes.
Radians. Not degrees. I don't want degrees. Degrees bad. Radians. Remember radians, Jingdong? Do you? Jingdong. 360 degrees equals 2 pi.
Is
Yes.
this even?
That's called radians. And this is called degrees.
180.
Degrees, radians.
Oh.
I want this one, not this one. Okay.
Is this even?
Wait. So this is pi over 6. And here is 4t. So I bring the 4 down, I get pi over 24 equals t.
Yeah.
Now he wants the a. So I can use this formula because now I know this, I know this, I know this, and I know this. So I can find the a. So let me write it here. A equals minus omega squared.
No, minus a over the square.
And then you have an a, which is 2. And then you have a sine omega t. Please calculate this on your calculator. Tell me what you get.
It is
Sin
minus 4.
Sin 4 pi over 24.
What's written there?
Yeah, sine 4 pi over 24.
Okay.
So 2. It's minus 8.
That'll be pi over 6, which is a half, isn't it? Which can yeah, so it's going to be just minus 16 meters per second squared.
There's no 4. There is 4. Yeah.
Sorry, it's not clear. 4.
Yeah.
And can you go up?
Yes, okay.
And question.
Here?
No, go up.
Here?
Yes. How to get the 4 on root 3?
Where?
4 root 3.
Here? Here? Oh,
Okay.
sorry. Yeah, maybe I didn't say clearly. The question he asks is if v equals this, so he gives you this.
Uh-huh.
Oh.
He wants to know what does the a equal.
How do you get the 4?
Hmm? Yes?
How do you get the 4 then? 4 cosine 4t.
This it's in the formula.
So y is 2 4, yeah. The w will be 2. 2 squared is 4.
24.
Yeah, here must be 2.
Wait. This is the formula for v.
Okay.
And v is a omega. And a is 2 and omega is 4.
Ah, okay. I thought we use A.
Okay, can I go on, please?
So this is a different question.
Huh?
Different
The
question.
next part of the same question.
Oh.
Okay,
Can you give us that question?
what do you mean? Well, I'm going to upload this right now as you do the questions.
Will you put the video on the model?
I- I will, when you're working on these, that is, I will upload it onto Moodle as you work on these. So as soon as you go home, it's ready.
Okay.
Okay. Now, you have 5 formulas in total, right? I'm going to give you formula number 6 now. And formula number 6 is A equals minus omega squared x. And this is a good formula like number 5 because this can be any time and this can be any time.
And can we explain what's A mean again?
A is acceleration.
Acceleration.
Yes. You know acceleration? A is this, acceleration.
Oh.
X is meters. Okay. Now what I'm going to do now to show you this formula is I want to do the last question again, but using this formula instead. Can we all watch? So, what do we know? We know that A equals 2, omega equals 4, and V equals, what did I say, 4 root 2?
3.
4 root 3. And I want the A.
Again?
Yeah, again, but using a different formula.
We have to get X.
And I want the A again.
Yeah, we have to get X.
So, formula number 5 and number 6. Number 5 told me that, what was it? V squared equals A squared,
No.
No.
Because
omega squared.
Yeah, omega squared.
is
A squared minus X squared. And my new formula is A equals minus omega squared X.
So it can.
So
omega,
using-
omega will go.
Yeah, using formula number 5, I get 16 times 3 equals 16 times 4 minus X squared. Yes? Are you clear with this?
yeah.
So they cancel. Yes? And here I get X squared equals 1.
Yeah.
Yeah.
So X equals plus or minus 1 meter.
Mhm.
Now, what formula will I use now?
The A
Number
is-
6.
Yeah.
A equals minus
Omega.
omega squared, which is 16,
Minus 1.
times plus or minus 1.
No, minus 1. Okay, yeah.
Yeah. So that equals plus or minus
16.
16. What answer did I get the other way? Yeah, I got minus 16. What's the problem? Well, this formula is a lot quicker, yes, but it doesn't tell me the direction.
Uh-huh.
So if they only want the size and not the sign,
Use the number 6.
use 5 and 6. Okay? You know what I mean, Xingdong? The size here means the number. So if they only want this, and they
Use number
don't
5,
care
6.
about this, then you can use formula 5 and
Let's
6.
say the magnitude A,
Yeah, if they say what's the magnitude of A,
so
use 5 and 6. But if they say what is the A,
so,
then they probably want the sign too.
so can we go up and
Yes. Here? Well, it starts here only. Go down?
No,
Yeah. Oh.
Well, go down a little bit.
even though.
Even now.
Yeah.
So how many formulas do we have for simple harmonic motion? Basically, we have 6.
For body.
How many did we have for circular motion? I think it was like 4, wasn't it? 4 or 5? And how many do we have for UVATS?
Go down. No.
3. Was 3 formulas. Yeah, that's all. Okay, if you write this down and if you're finished writing this down, please try worksheet number 2.
You told me that amplitude is big A, right?
Yes. Amplitude is big A.
And periodic time, the small t or
The
big?
periodic time is the big T.
2.7 second.
Okay, let me stop the recording.